We now want to look at a plane. And planes can be completely described by either 3 points or equation with 2 free variables. So I can have u plus tv plus sw, where u, v, and w are actually just the points that determine my plane. And this is one way to do it, but there's also the normal form version of a plane. The normal form of a plane that does not pass through the origin is of the form a1x1 plus a2x2 plus a3x3 equal to 1, where the a's are known coefficients. And if the plane passes through the origin, it will instead be equal to 0. So let's look at some examples on how we can use this. Here's an equation of a plane, and we want to put this in parametric form. In order to do that, we start by solving for x1. That gives us that x1 is equal to 4 over 7x2 minus 5 over 7x3 plus 8 over 7. And then we start writing this in vector form. I have x1 is 4 over 7x2 minus 5 over 7x3 plus 8 over 7. I know nothing about x2, so I just write an x2. And I know nothing about x3, so I just write an x3. And then from there, we can go ahead and break this up and factor out our variables. When we do that, we get 8 over 7, 0, 0, plus x2, 4 over 7, 1, 0, plus x3, negative 5 over 7, 0, 1. Here I have 3 points, and I want to find the normal form of the plane that contains these points. That means we want to put it into this form a1x1 plus a2x2 plus a3x3 equal to 1. But we have our values for x1, x2, x3. If I stick in my first point, that gives me 2a1 plus 0a2 plus 1a3 is equal to 1. Sticking in my second point gives me negative a1 minus 2a2 minus 3a3 is equal to 1. And then my third point gives me negative 7a1 plus 1a2 minus 3a3 is equal to 1. So now I have a system of equations. We can then put this into a matrix and then row reduce it. When I do, I get the solution as 4, 8, negative 7. So these are my values for a1, a2, and a3. So we have the normal form 4x1 plus 8x2 minus 7x3 equal to 1.